The first thing we want to do is take a look at tangent and cotangent. And what I'd like for you to do is to sketch the graph to the best of your ability.
Stop.
Trying to do it from memory is kind of rough, can't it? And that suggests to you that just trying to do it from memory is probably not an effective strategy. What you want to do is to know how to think through it. Yeah. Can anybody suggest a good way to think through it? Of course, mine's just like classic reading. So, what is an effective way to think through tangent so as to come at a graph of it?
As sine over cosine.
As sine over cosine. That's exactly right. Because once I write it in terms of sine and cosine here, now I can think in terms of poles, and zeros. Okay. If you struggled with this graph, at this time I'd like for you to find the zeros of tangent and the vertical aspect of tangent. Go. On the interval 0 to 2. And what do you get for the zeros of tangent? Fill it apart. Zero. Is that the only one? Maybe. What equation is he really trying to solve? Sine x equals 0. Right. Looking for the zeros. Trying to solve sine x equals 0. I think you know the solutions of sine x equals 0, right? What are they? Yeah. So that is a 0, but it's not the only one.
Why don't you just say like k pi?
Yeah, it's going to be every multiple of pi, pi, and 2 pi, etc. So there are your zeros. What about your vertical asymptotes, Lindsay? Yep. Yeah, let's call it 2n plus 1 pi over 2 so that it's just the odd ones. Yep. We do n plus 1, that's all numbers. Right? Yes. Okay. Now, armed with that, I'm ready for a sketch. I'm going to have a vertical asymptote at pi over 2. And another one here at 3 pi over 2. And I'm going to have zeros at 0, pi, and 2 pi. Okay? Now, how does the graph go from here?
So
My options are up or down.
it starts going up
How do you know?
because if you at pi over 4, you know that it's going to be positive 1,
Yeah, that's right.
and so
The graph goes up like so. I
it has
agree.
to go up, and then at 5 pi over 4, it's at positive 1 again.
Here.
Yeah.
Yep.
So it's going to go up.
And it's
then-
going to go up
like that.
Yep. And then it's going to go up like that. Okay. Good. So does everybody see how the sketching process works? We identify zeros and vertical asymptotes, and then we just have to figure out where is it positive, where is it negative. And we can do that straight off of the circle. This process of sketching tangent took us about 5 minutes. It should take you about 30 seconds. So how do we take something that takes us 5 minutes and turn it into something that takes 30 seconds?
Practice.
Practice. That's right. You need to practice this. Not like it would be kind of cool if maybe you practice this, but it's like you should have learned this last year, but you had too many snow days, so you didn't learn it last year, so you need to really practice this so that you can sketch your trig functions. That's a basis thing. All right. Cotangent. Use the same process to get a graph of cotangent. Go. What would Did you find holes and holes first and zeros?
Yeah.
What would you get for your vertical asymptotes? Could it be 0 then? Yes. Okay, where is cotangent x equal to 0, Nicole?
Pi over 2 and 3 pi over 2. So
In general, we'll call it
2.
2n plus 1, odd multiples of pi over 2. And where is cotangent non-existent? In other words, generally, n times pi. Yep, that's exactly right. So we have our vertical asymptotes now at 0, pi, 2 pi. And we have zeros at pi over 2 and 3 pi over 2, like so. So the only question is positive or negative. Does my graph start down here in the negative, or does it start up here positive? And how do you know? Go. Up or down? Up. How do you know? That's right. If I take any angle in the first quadrant right here, I'm going to get a positive value. And so my graph is going to start positive and go negative, just like that. Now, let's put these two graphs side by side. And I want to observe a couple of things. First of all, we can mark up quadrants. From 0 to pi over 2 is quadrant 1 on your unit circle. Does everybody see what I'm saying here? And pi over 2 to 2 pi pi is going to be quadrant 2, quadrant 3, and quadrant 4. So one way you can check yourself is to just do a spot check of values. If I go into somewhere into quadrant 3 right here and pick maybe 5 pi over 4, my tangent should be a positive value because sine over cosine will be positive. And sure enough, in quadrant 3, my tangent is positive. So is my cotangent. Okay? So those are the graphs. And those need to be practiced until you can do them without having to think too much. It's not memorizing. Instead, it's practicing a thought process. Okay. Next question. What are the derivatives of tangent and cotangent? And rather than do a limiting process here, we are going to leverage our derivatives that we got for sine and cosine. For Lindsay's benefit, since she wasn't here yesterday, let's remind ourselves here, when we did the math, what did we get for the derivatives of sine and cosine? The derivative of sine x is sine x. The derivative of cosine x is negative sine x. Very good. And so now we're going to leverage those two derivatives to get the derivative of tangent by writing it as the derivative of sine over cosine. And what I would like for you to do at this time is to take the derivative of sine over cosine using, of course, what derivative rule? The quotient rule. Go. Charlie, tell me how it goes.
Well, you do low d high,
Okay,
that's d low.
okay.
So, cosine of x times cosine of x
Mhm.
minus sine of x times sine of x.
You're exactly right. I'm going to do that in 2 steps, just so we can all see the math clearly.
No, I don't like it.
And then on the bottom,
Denominator squared, so cosine squared x.
cosine squared x. And then you had this as cosine x times cosine x. And then what happens when I do the minus sine x times minus sine x?
Plus sine squared x.
Plus sine squared x. Okay. Now what?
And the top equals 1.
Yes! Big idea here. The top is in fact 1. So that the derivative of tangent is in fact equal to 1 over cosine squared. This is a perfectly respectable answer. The cool mathematicians like to write things without quotients if possible, so they're going to write this as secant squared x.
Derivative of cosine is equal to
1 over cosine secant squared
so
x
sine x times the
secant squared is 1 over cosine squared.
sine squared x.
Okay.
Cosine squared x.
Armed with that, I'd like for you to now come up with the derivative of cotangent. Go.
Yeah.
Okay. Got it? Where is it? Okay. Okay. You want to come do it? Come do it? You can do it. Because you can. When you push, press with intent, not really hard, but firmly. Okay?
Your handwriting is
So beautiful. Oh,
Nice. Is she good so far?
Wait. Yes. Yes.
Yes. She's good so far.
It's cosecant squared.
Hold on for just a second. No,
Oh wait, no, I know, I forgot that the middle column is
No, it's okay, but I'm not sure it's correct there.
Why?
Why is it
Yeah.
Huh?
No, that should be negative sine squared minus cosine.
Oh wait, I'm sorry.
It's okay.
Just right, it's an eraser.
And it's a negative sign.
Okay. So,
Gloria, negative sign.
Negative
Where?
sine squared.
Negative.
Oh,
Negative sine squared x.
No.
oh
Below, right there, yeah.
okay, slow up. Why negative sine squared?
because this is sine, negative sine x.
Yeah, the derivative of cosine x is negative sine x, right? Now she's back to the set. Oops, slow down. Go up.
Oh, I know.
There you go.
I know. I saw, I know.
She's nervous.
Yeah, I don't like this.
Yeah, give her a hand. Good job. So, by the way, how many of you successfully got to negative cosecant squared? Anybody work up the negative signs? Anything's happening? Okay. So let's do a catalog so far of what we got. What do you notice about the derivatives of the trig function so far? How do they relate to one another? Not exactly a reciprocal relationship. But what do you notice about this side in comparison to this side? Two things. Right. The right-hand side is negative.
They're squared.
And what is the other thing that you notice about the right-hand side compared to the left-hand side?
It's with the bottom.
Yeah? We need a word here. I'm going to give you a word. These functions are the co-functions of those ones. By the co-function, I mean the function of the complementary angle. So the co-function of cosine is sine. The co-function of secant is cosecant. So what we have are negative co-functions on this side. That helps us, organizing like that helps on memories, right? Because we're going to end up with 6 of these trig derivatives. And what are the chances that you might forget one? That's positive, good. So observing that the right-hand side there are the negative co-functions of the left-hand side means we really only have to remember 3. Now, last thing I want to observe is this. Secant squared x. Notice that secant squared x is always going to be a positive number when it exists. And therefore, I expect that the graph of tangent should be an always increasing function. Is it? Let's go back to our graph here. Does my tangent graph always have a positive derivative? Yeah, it does, whenever it exists. And likewise, my cotangent function always has a negative derivative wherever it exists. The derivative of cotangent is negative cosecant squared x. Okay? So that helps us a little bit remember and think through the graphs as well. Okay, what do we have left to do? Secant and cosecant, that's exactly right. Yeah, no song, sorry about that. I don't know. Might have to come up with some kind of like rap or house music. All right. Well, you know the plan. We're going to first ask you to sketch a derivative. excuse me, first ask you to sketch a graph of the function, and then we'll compute its derivative. So we should have no zeros at all. And the vertical asymptotes occur at odd multiples of pi over 2. Okay. And in this quadrant, we're clearly going to be positive. In these two quadrants, we're going to be negative, and our highest value here is going to be -1, right at pi. And then positive again. If we were to keep the graph going, it would look like this. And hey, look, horseshoes. Ah, yeah, that's a really good point. So since cosine is between -1 and 1, the reciprocal of cosine is going to be, yeah, you're flipping it inside out. It's going to be greater than 1 or less than -1. Exactly so. Here? Yep. So since the, let's do the positive one. It's a little bit easier to think through. Since the largest value of cosine is 1, the smallest value of 1 over cosine will be 1 over 1, which is 1. Yep. And everything else gets bigger from there. Okay? Go ahead and graph cosecant also. So you should have vertical asymptotes at pi and 2 pi. And right at pi over 2, we have our smallest value, which is 1. And in quadrants 1 and 2, we're going to be positive. Right at 3 pi over 2, we have our largest value here, which is -1. And on that side, like so. And on the graph continues. So horseshoes again. Now, what about derivatives? Well, you can probably tell where I'm going to go with this. I'm going to replace secant x with cosine and quotient. Cosine times the derivative of 1 minus 1 times the derivative of cosine. All of that divided by cosine squared. Now the derivative of 1 is 0, right? cosine x times 0 is 0 again. So what I'm left with when the dust settles is minus 1 times the derivative of cosine x, or positive sine x over cosine squared x. This is a perfectly good answer. However, we'd like to rewrite it without quotients. So I'm going to cleverly peel off one factor of cosine in the denominator and rewrite like so. And I now see that this is equal to exactly secant x times tangent x. The derivative of secant x is secant x times tangent x. That was not the result we were necessarily expecting, was it? Yes?
Could we leave it as sine x over cosine?
You can, but all the cool mathematicians would laugh. So yes, it is correct. But it is almost universally written as secant. And the reason for that is just sort of associating in mind the secants and the tangents with each other. The derivative of tangent is secant squared. The derivative of secant is secant. Actually, there's a historical reason also. Until very recently, meaning like the 19-whatevers, it was kind of hard to lay out typeset with quotients and exponents and so on and so forth. It was more work. And so anything that you could do to eliminate quotients in your typesetting was a good thing. Okay? I think we need a derivative of cosecant. Make it so. Once you're finished, what you can do is make yourself a nice little chart of the 6 trig derivatives for studying purposes. Part of your job tonight is to memorize those 6 so that you have them firmly in your mind. Why the negative sign? There you go. Does that fit with our pattern, by the way, of negative cofunctions? Yeah. Yeah. Just a pure matter of strategy. This times so you're right. Those this is
I don't know. I was so surprised I got a B. I was like, dang, I got a B from 33 to a B. Wow. Like, within like 2 weeks. Within 2 weeks, I read it. Like, it's crazy. Yeah. Oh, shoot.
While he's doing a little bit of work here, rather than stare at him, I'm going to talk to you about strategies for getting these firmly in your mind. The 6 trig derivatives need to be known. And there are 2 ways that you can work that. One is you can try straight memorization. Some of you are fans of, I'm just going to memorize it. The advantage of that is that you can cram it all into your brain cells right there, right before a quiz or test, and then you flip the problem with it. It all leaks out. In fact, it doesn't take very long. Sometimes people cram for a quiz or test in the second period, and then by 7th period, it's all gone. That's not effective learning, right? The reason that you are in this class is not actually to take quizzes and tests. It's the way it happens. And so, if you are doing it by the memorization method, then probably it needs some supplementing. So how do we supplement that? So that it goes into the long-term memory. The trick for memorizing the derivatives is to walk through the derivative taking process. So that if you do what we did today, which is rewrite in terms of sine and cosine, take derivatives using the quotient rule, if you do that process for yourself only 3 times, you'll know it. That's it. And so as you head towards memorizing these, which you need to have done by tomorrow, I encourage you to derive them for yourself. So you want an English class. You go, what's the derivative of tangent?
Why English class? I want to know why English class.
It's always English. I pick on English. But what's the class you would sit bored in the most? History. English. This is I'll talk to that guy. I know.
Oh, no, no.
That's pretty good. Why is this true? Good. Very good. Just want to make sure we give the hand, guys. Yes.
Should the negative be the cosecant one instead of cotangent?
Oh, that's a great question. It doesn't matter.
Okay.
And the reason it doesn't matter is that we are multiplying 3 things here. We're multiplying -1 times cotangent x times cosecant x. And I can multiply those in any order. Yep. Excellent. Well, our goal was to get through the trig derivatives and the graphs, and we accomplished our goal. So your goal is to become familiar and comfortable with those. By the end of the year, they will be like old friends. At this moment, they're all a little strange. So your task is to get from here to there. See you later.